Straight-through cable. A straight-through cable, also known as a patch cable or straight cable, is a type of Ethernet cable that is commonly used to connect a computer, router, or switch to a modem, hub, or another network device. The wiring configuration of a straight-through cable is the same at both ends, with pin 1 connected to pin 1, pin 2 connected to pin 2, and so on. In a straight-through cable, the wires are arranged in a specific order based on the T568A or T568B wiring standard. The T568A standard is typically used in residential networks, while the T568B standard is commonly used in commercial and enterprise networks. Both standards use the same wiring configuration, but the order of the wires is different. The wiring configuration of a straight-through cable T568A standard is: pin 1, white-green, pin 2, green, pin 3, white-orange, pin 4, blue, pin 5, white-blue, pin 6, orange, pin 7, white-brown, pin 8, brown. T568B standard: pin 1, white-orange, pin 2, orange, pin 3, white-green, pin 4, blue, pin 5, white-blue, pin 6, green, pin 7, white-brown, pin 8, brown. Overall, straight-through cables are an essential component of Ethernet networking and are widely used in both residential and commercial networks to connect devices to the Internet and to each other. Crossover cable. A crossover cable is a type of Ethernet cable that is used to connect two network devices directly to each other, such as two computers or two switches. In contrast to a straight-through cable, which has the same wiring configuration at both ends, a crossover cable has a different wiring configuration at each end. The wiring configuration of a crossover cable is: pin 1 at one end is connected to pin 3 at the other end. Pin 2 at one end is connected to pin 6 at the other end. Pin 3 at one end is connected to pin 1 at the other end. Pin 6 at one end is connected to pin 2 at the other end. The purpose of the crossover cable is to allow two devices to communicate directly with each other without the need for a hub or switch to act as an intermediary. In a typical Ethernet network, data travels from a computer through a switch or hub to another computer, but with a crossover cable, data can be sent directly from one computer to another. Crossover cables are less common than straight-through cables, but they are still used in some networking scenarios, particularly in peer-to-peer networks or when connecting two switches together. Some modern network devices are capable of automatically detecting and adjusting for crossover cables, making them more versatile and easier to use. Rollover cable. A rollover cable, also known as a console cable, is a type of Ethernet cable that is used to connect a computer or terminal to the console port of a networking device, such as a router, switch, or firewall. The console port is typically used for initial configuration, troubleshooting, and monitoring of the networking device. The wiring configuration of a rollover cable is: pin 1 is connected to pin 8, pin 2 is connected to pin 7, pin 3 is connected to pin 6, pin 4 is connected to pin 5, pin 5 is connected to pin 4, pin 6 is connected to pin 3, pin 7 is connected to pin 2, pin 8 is connected to pin 1. The purpose of the rollover cable is to allow a computer or terminal to communicate with the networking device using a serial connection. When the cable is connected to the console port of the networking device and to the serial port of a computer, the console port will display the device's command line interface, allowing the user to enter configuration commands, view status messages, and perform other administrative tasks. Rollover cables are commonly used by network administrators, technicians, and engineers to manage and configure networking devices. They are typically included with the networking device or can be purchased separately. Auto-MDIX. Auto-MDIX, Automatic Media Dependent Interface Crossover, is a feature found in most modern Ethernet switches, routers, and network interface cards that allows them to automatically detect and configure the appropriate wiring configuration for the Ethernet cable being used. Traditionally, Ethernet devices use either a straight-through or crossover cable depending on whether they are connected to another device or to a hub or switch. A straight-through cable is used to connect devices to a hub or switch, while a crossover cable is used to connect devices directly to each other. However, with the advent of Auto-MDIX, this distinction is no longer necessary. When Auto-MDIX is enabled on a device, it will automatically detect the type of Ethernet cable being used and configure the wiring configuration accordingly. This means that a straight-through cable can be used to connect devices directly to each other, without the need for a crossover cable, and vice versa. Auto-MDIX is a useful feature for simplifying network setup and troubleshooting, as it eliminates the need to worry about which type of cable to use for a particular connection. It is supported by most modern Ethernet standards, including 10-T, 100-TX, and 1000-T. Fiber optic connections. A fiber optic connection is a type of network connection that uses fiber optic cables to transmit data. Fiber optic cables are made of thin strands of glass or plastic fibers that transmit data using light instead of electrical signals. Fiber optic connections offer several advantages over traditional copper-based connections, including high bandwidth. Fiber optic cables can transmit data at much higher speeds than copper cables, making them ideal for high bandwidth applications such as video streaming, online gaming, and cloud computing. Long distance transmission. Fiber optic cables can transmit data over much longer distances than copper cables without experiencing signal degradation, making them ideal for long-distance connections such as between different cities or countries. Immunity to electromagnetic interference. Fiber optic cables are immune to electromagnetic interference, making them less susceptible to noise and signal loss compared to copper cables. Security. Fiber optic connections are more secure than copper connections because they are difficult to tap into without physically accessing the cable. There are two main types of fiber optic connections: single-mode and multi-mode. Single-mode fiber is designed for long-distance transmission and is used for connections that span several kilometers or more. Multi-mode fiber is used for shorter distances, typically less than a kilometer, and is less expensive than single-mode fiber. Fiber optic connections are commonly used in data centers, telecommunications networks, and high-speed internet connections. However, they are also increasingly being used in homes and small businesses as the cost of fiber optic equipment and installation continues to decrease. Multimode fiber. Multimode fiber (MMF) is a type of optical fiber that is designed to carry multiple modes or paths of light at the same time. This is achieved by increasing the size of the fiber's core, which allows light to reflect off the walls of the core at multiple angles. The larger core size means that more light can be transmitted, but it also means that the signal can degrade over longer distances. Multimode fiber is typically used for shorter distance transmissions, such as within a building or campus. It is commonly used in LANs, local area networks, data centers, and other applications where high-speed data transfer is required over relatively short distances. There are several types of multimode fiber, including OM1, OM2, OM3, and OM4. The OM stands for optical multimode, and the number refers to the fiber's bandwidth capacity. OM1 and OM2 fibers are older and have lower bandwidth capacities, while OM3 and OM4 fibers are newer and have higher bandwidth capacities. OM4 fiber is capable of transmitting data at speeds up to 100 gigabits per second over distances up to 150 meters, while OM3 fiber can transmit at 10 gigabits per second over distances up to 300 meters. Multimode fiber is typically less expensive than single-mode fiber and can be used with less expensive light sources, such as LEDs, instead of more expensive laser sources. However, it is also less reliable over long distances and is more susceptible to signal distortion caused by modal dispersion, which is the spreading of the signal over time due to the different path lengths of the multiple modes of light. Single-mode fiber. Single-mode fiber (SMF) is a type of optical fiber that is designed to carry a single mode or path of light at a time. It achieves this by having a much smaller core diameter than multimode fiber, typically around 9 microns, which allows only one path of light to be transmitted. This design minimizes the signal distortion caused by modal dispersion and allows for much longer transmission distances and higher data rates. Single-mode fiber is commonly used in long-haul telecommunications networks, undersea cables, and other applications where high-speed data transfer over long distances is required. It can transmit data at speeds up to 100 gigabits per second over distances up to 10 kilometers and beyond. Single-mode fiber is more expensive than multimode fiber and requires more precise alignment with the light source. It also requires more expensive light sources, such as lasers, to generate the narrow beam of light that is needed for single-mode transmission. However, It offers several advantages over multimode fiber, including longer transmission distances. Single-mode fiber can transmit data over much longer distances than multimode fiber without experiencing signal degradation. Higher bandwidth. Single-mode fiber has a much higher bandwidth capacity than multimode fiber, which allows for higher data rates. Lower signal distortion. Single-mode fiber is less susceptible to signal distortion caused by modal dispersion, which results in clearer and more reliable data transmission. Overall, single-mode fiber is the preferred choice for applications that require high-speed data transfer over long distances, while multimode fiber is better suited for shorter distance applications. UTP versus fiber-optic cabling. UTP, unshielded twisted pair, and fiber-optic cabling are two different types of cabling used for networking and data transmission. Here are some of the differences between the two. Speed. Fiber-optic cabling is capable of much higher data transfer speeds than UTP cabling. UTP cabling is typically limited to speeds of up to 10 gigabits per second, while fiber-optic cabling can support speeds of up to 100 gigabits per second or higher. Distance. Fiber-optic cabling can transmit data over much longer distances than UTP cabling without experiencing signal degradation. UTP cabling is typically limited to distances of up to 100 meters, while fiber-optic cabling can support distances of several kilometers or more. Security. Fiber-optic cabling is more secure than UTP cabling because it is more difficult to tap or intercept. UTP cabling can be more easily intercepted using specialized equipment, while fiber-optic cabling requires more specialized equipment and knowledge to tap. Cost. UTP cabling is generally less expensive than fiber-optic cabling, especially for shorter distances. However, for longer distances or higher data rates, fiber-optic cabling can be more cost-effective because it requires fewer signal repeaters and has lower maintenance costs. Susceptibility to interference. UTP cabling is more susceptible to interference from nearby electrical devices, while fiber-optic cabling is immune to most types of electromagnetic interference. Overall, the choice between UTP and fiber-optic cabling depends on the specific needs of the network and the application. For shorter distances and lower data rates, UTP cabling is often sufficient and more cost-effective. For longer distances and higher data rates, fiber-optic cabling is typically required to ensure reliable and high-speed data transmission.